You look at the look because it's an opening as well, but it's so anyway, the worst case I would just say not so well. We can
Yeah, Europe. Yeah, I mean, honestly, I'm,
I forget all the So it did go up from you.
Because I came to play my two artists, so I said, well, sure. And he couldn't deliver. No, I'm just I'll figure out California. But I'll find him. He actually figured it out. Sure, but not all the people who were signed. So he now basically he realized sure he was left with Excel. I can't do it. I don't need Excel.
So we can find it online tomorrow?
Right.
Well, I mean, get more people.
It would be cool, you know.
I know.
It's okay. We're out having that a day. Yeah, that's a good one. So I apologize. I finally opened here that I heard the session. Yes, it was good here, but I still keep the bottom.
Oh, yeah.
Special bottom.
I know people who won't open it.
That's good. I don't know actually whether you really keep the beer not in a special environment.
It's
Even wine, you need to have a special cellar to keep wine.
so I got a handful of them.
But you probably keep it compatible because okay.
Ice has got. We actually didn't do. Green ones. You've seen them too.
Fake. Actually, it's important to the tour on the winery.
Feel better? Feel better? For those, yeah.
So, and there is only one type of port. It's a fall collection. Okay. That where when they make it, so the little pieces of leaves and branches get in, and that port gets better. Everything else you cannot really keep long time because it goes bad. So port is something.
Did you sit there? I was just gonna get.
You want me to only one that I the room?
We got a first sign.
And one of the sticks
It starts at 50.
50. Yes, we always put that.
Wow. Well, I know these are getting. I'm afraid to keep them closed in a warm room.
No, keeping in the fridge probably.
So, we're good. Glad you enjoyed it.
Oh yeah, absolutely.
We want to do another version.
Okay, so I'll write some documents. Sure, on this.
Just-
You sign it as well?
Negative or cucumber.
So, Greg, I noticed that you was asking for shepherds. Probably cannot be a shepherd by my
Shepherd something else.
Good afternoon.
I'll look up because actually all the three documents.
Hello, hello, hello.
That's okay. You can go on.
Hello. All the beer guys in the back. Hello. What? Yeah, the back. So this is the always very exciting routing area open meeting. This is IETF 101, and we're in London. Deborah is still Deborah, I'm still me, and now Aliyah is Martin over there. Say hello. Say hello, Martin.
Hello.
There we go. So all of you noticed, of course, that last night, because I'm sure most of you were at the plenary, we had the exchange of dots. And so now Martin has a yellow dot, and he's the new routing area ID. We're very happy to have him on board, of course, and we're giving him all the action items from now on. Nodewell, this is the Nodewell. I have seen in some of the working groups that I've been in that not all of you updated the Nodewell. Please update it. It pretty much says the same thing as before. The difference is that now we made it, I think, simpler, and we point to all the BCPs down at the bottom, so that it's a lot simpler for people to go find other things to refer to. There's also a lot of other information about the area, the agenda, the routing area general list, which is the routing discussion list, etc. The blue sheets are going around, of course, so you can sign that in there. As always, we want to ask you to please review documents. The quality of the documents is, of course, proportional to the reviews that we get, hopefully. And we want to invite everyone to do that. Review the documents in your working group. For the people in the routing directorate, thank you so much for all the work that you do, for all the reviews that you do as well, in helping us getting higher document quality. We're always looking for feedback. What are we doing well? What is working well with the area or not? Any comments that you have about us or about the area in general, you can give it to us, especially to Martin, who is the one who needs the most help right now. Yes?
Is it the other way around?
No. See, that's how well we take feedback. No. Okay. No, seriously. Anytime you can, of course, find us in the hall or email or whatever you want. It's easy. Should be easy to get a hold of us. We do want to hear how we're doing. So this is the agenda for today. We have, of course, all the administration stuff. There are some updates to the area that we, of course, want to share with you guys. Then we're going to have a talk on deterministic networking. The chairs from the networking group are going to present that. And then the always exciting and never boring working group and BOF reports. We didn't have a BOF this time, but all the working groups and the routing directorate report that John and Amy put together and run all the time. And then some open discussion at the end if we have time. So does anyone want to bash the agenda? Okay, I do, actually. So we have some time issues, and we're going to change the agenda a little bit. We're going to move the deterministic networking first. So we're going to run that first, and then we're going to come back to the rest of the administrivia and the rest of the agenda. Anyone opposed to that? No? Good. Because that's what we're going to do. So Janos and the rest of the chairs. So this is Janos, Lou, and Pat, who is not here yet.
She's outgoing, you know what happens to that. Okay.
Yes. This works.
Thank you. Thank you, Alvaro. So it's just a brief overview of the .NET Working Group.
The bigger screen doesn't work, so you need to look at.
Okay, I see. And which this navigation doesn't seem to work. Now, finally. So a bit about what is .NET. So .NET aims to deliver guaranteed delivery in terms of both timing and loss, reliability aspects. So deterministic means that the bucket delivery is deterministic in time, and we are after very low delay and delay variation values and extremely low loss values. This work is done in collaboration with the IEEE 802.1 TSN task group. We develop a common architecture. So if the lower layer is TSN, then in order to achieve these strict QoS requirements, you may need TSN features as well. It's very good to have a common architecture. Very important in the bottom, we are not looking for the big I internet. This is all about a single administrative domain. So there are a number of use cases. We have a use cases draft that lists all these and explains the requirements of these use cases and what these use cases expect from .NET. I would like to mention a couple of these or highlight like 5G in multiple aspects to provide deterministic transport for the 5G radio transport part, like front haul, back haul, and so on. That's one of the candidates. Industrial automation, I think it's very important, Industry 4.0. In a factory floor, there's a change in networking, and they are looking at hierarchy as well. So .NET, I think, has a role. Power generation, as part of power generation, the wind farms, building automation, and so on. So this is just a brief illustration of the use cases. There's a link in the bottom of the slide to the draft if you are interested in more details. This doesn't seem to work. I'm pushing this. Okay. What is the difference between what is deterministic in terms of what is the difference between a traditional service and a deterministic service? In case of a traditional service, we are having a kind of elastic traffic, and well, we are networking guys. We are network centric in the sense that we want to have a high utilization, maximum throughput, and so on. And of course, we have been always interested in a good latency, providing good delay values, but not the extreme ones. As illustrated in the bottom, the delay curves typically have a tail. And if you introduce a bound to this delay curve, it means that we either lose packets at the tail of the curve, or we need to over provision. So it's not efficient network utilization. As opposed to it, on the right-hand side, the deterministic service characteristics are described. As I mentioned, the target is very deterministic delivery, meaning that low delay variation. So it is service-centric. The service characteristics and parameters and requirements are very important. We need to provide zero congestion loss in the network in order to achieve these targets, the bounded latency. And the delay probability curve we are looking at is bounded, so it's different if you compare to the two figures in the bottom. So what we are after that is in-time delivery. I mean, sending the right packet or deliver the right packet at the right time. We have brought here a demo which unfortunately got broken during the dry run. While we discussed how to project it, it just was running for 1 minute and many things got broken, like the power and so on. So if it's a demo daemon, if some small piece gets broken, then it's a chain. So can we show something? Okay, I still keep talking, explain what it is. We will distribute a video link to the demo. It has been shown a month ago or 2 months ago at an IETF workshop with IEEE. So there's a video recording of it, and some part of it actually has been shown in Prague. So I can explain what was that. So the demo setup, what we have here is there is this special display, this rotating display, which provides a persistence of vision kind of display. It's a column of LED, and it rotates at a high RPM, like 5,000, which gives you the display. As illustrated in the bottom, we have the content is remote. It can be in a cloud, and we have a network in between. So in this implementation, it is not in the cloud. It's the far remote green board is the one sending the picture, and we have a simple control loop, meaning that the display with the rotation sends a trigger to the cloud, and the content, the timing, and everything is done in the remote part. And the content is sent to the display, and the display is very simple. It puts immediately on the screen what has been sent. So this control loop has to be precise, and if anything disturbs, like any other traffic or networking stuff, that is bad for the application. We demonstrate two aspects with this demo. Primarily, this is an illustration device what we built ourselves for showing very low packet delay variation, like in the range of 100 microseconds. So the first part of the demo shows that at a very simple case, if all the traffic is in the same queue, then the displayed content is a mess. We can apply very simple techniques like strict priority. We can give high priority to the picture, but still, if you have a background traffic, the background traffic actually would be sent from the laptop. That can disturb your content because it's, despite of being lower priority, if it is being already the transmission has been already started, you have to wait. So if it is huge packets, then you have to wait for the transmission. So this is where the delay variation, actually depending on link speed and packet size, that's what it depends on. And what we would show is a kind of 200 microseconds delay variation, which means the image is shaking. So it is circles you saw partially. It circles what we use, and the image shakes if there's a delay variation. If you imagine this is in a factory, like a machine, like creating a particular surface, this delay variation is not tolerable. If coming back to the use cases, if this particular service is a wind turbine and you get this delay variation or some disturbance, that wind turbine goes to the trash. And one of the techniques to provide deterministic latency is preemption, which is a simple concept. It is a link locale here, and an express packet can preempt the transmission of a lower priority or less important preemptible traffic. So you don't have to wait the transmission of a whole lower priority traffic, but the express traffic gets transmitted. And the demo shows that the image becomes still again. So you can see it on the video. As I said, the link will be distributed. So this is the latency aspect. And we also implemented and can demonstrate and demonstrated in Prague the protection aspect for the reliability, ultra reliability, very low loss. This is a per packet protection. We call it packet replication and elimination in .NET. So it is a kind of 1+1 redundancy when we send duplicates of packets in the network. As you see, there are two disjoint parts. There is a replication point that adds a sequence number to the packets, and the elimination point keeps only one of the packets with the same sequence number and deletes the extras and sends one copy onwards. We used the Lego robot to demonstrate it before, even in the video recording we will distribute or the last Prague meeting. In that case, the application is that the balancing logic is not on the balancing Lego robot, but in the cloud. And if there is a loss, moving on to the particular, before that, the data plane we implemented it is the data plane solution 00 status that was prepared for the Prague meeting. It is the MPLS encapsulation with a transport label, service label, and .NET control word. So that's what it is on those PCs. Actually, the PCs implemented the ring topology I show in the figure in below. And here we investigate or take the two scenarios. A simple link failure when classic techniques provide 50 millisecond failover. And this in this setup means losing 2 or 3 packets. And with the Lego application, it is too much for the balancing logic having run over the network. The Lego falls over. With this display, what we could show is that the image gets completely crappy. And the other case is link flapping, which we often do not detect with classic techniques. So the linear protection is based on an OEM monitoring, and you switch over. If your link flapping is like 20 millisecond, it's below the time scale, you do not even notice. But if you have this very sensitive control application, one of those, then that will detect, and actually the effect is the same. Like your control loop is broken, Lego falls over, image gets broken. So that's the status before .NET. And what we have in .NET, this packet replication, if we turn this on, due to the per packet protection, even if we have a link failure in one of the parts, there is 0 packet loss actually, because there is no switchover time, no detection time. The packet just gets to the elimination point and it's sent onward. I am very, very sorry for not being able to show this demo. Or can we show anything? Just. Okay, let's see the protection at least. So let's see the basic scenario, the 50 millisecond failover protection switching, what we have. So this is the basic picture we use, circles. I don't think you should move that. Okay. Enough things have got broken today. I mean, even just power supply. Very strange things. Nothing, no flash, nothing. It's just. So this is what we want to have. And if we have a failure with 50 millisecond failover, then actually it's we will have multiple failures to be able to see repeated in 1 second. So 50 millisecond outages repeated in 1 second. So you see there is a white column in the beginning of the picture, and that screws up the image. So if you imagine this as a machine in a factory, that's too bad. Or if we have the link flapping case, when we have this on the right-hand side, illustrated on the figure, link goes up and down. Again, it's very bad for the picture. This is without pref. This is classical linear protection. And if we turn on the packet replication and elimination function of DetNet, now we turn on, it means that actually we need to reboot one of the virtual switches. So those 4 PCs are all virtual switches implementing this function and the MPLS data plane. So if we turn it on and do the same thing, either one, let's do the link failure, then you don't even notice anything because one of the packets goes through. So in the video recording, it's the Lego robot. We wanted to have only one device in this small table. That's why we brought this special one prepared for the latency. So moving on, I think time is running. I would like to give the word to Lou.
So first, I'd like to thank János and his colleague for doing the demonstration. And one of the nice things about this is, it's not a canned demo. You go to so many demos and everything works flawlessly, and how do you know it's really working? Well, this is a good way to show that we're actually doing something. So unfortunately, when everything works, when you're running the protection function, and you have the links breaking back and forth, you just get a solid picture. So it's still a little bit, you have to believe us that there's really.
So if I just 1 minute. So if we go back to the latency one. So if we see the basic one, if they get into the same queue, can you put it in the same queue? The picture gets smashed. So it's not the rotation we wanted to show, which comes in the next one. The image, that was the absolute congestion. And here comes the strict priority when the people sitting closer see that the image is shaking. That's where the rotation is very important, to have a high rotation and a wider picture because you see the shaking better. And if we apply the preemption, then the shaking disappears. So sorry to interrupt.
No problem.
Finally.
Well, thank you very much. Okay, so I'm going to sort of go back to what the working group is all about. I want to clarify one point that was on the slide that I didn't catch. In the earlier slide, János mentioned that we have limited scope. That's absolutely true. We're not trying to solve the internet problem. We think that that's, we'll come and solve that in maybe 10 to 20 years, but maybe that's too long. I don't know, but eventually we'll get there. In order to achieve something reasonable, we have a scope of, as he mentioned, a single administrative domain, but we actually also allow for multiple administrative domains when they are cooperating. So this could be, for example, a customer with its provider cooperating to deliver a service between multiple sites. That is certainly within our scope as well. And I think that's an important distinction. In terms of what we're trying to deliver, there's excuse me, 3 core functions or services. The first is protection from congestion. And the thing I always like to talk about is something that Norm Finn, who was one of the people who worked on this early, talks about is zero congestion loss. So we want to make it so that when you have a DetNet service, when there is contention in the network, the services that receive the zero congestion loss service don't see any packet loss whatsoever. Now, we can't fix the line problem with good queuing. We could fix it with protection like you've seen here with PREF, which is actually the last one with service protection. Along the way, we also have latency control. You saw the need for that in the demo already, so I don't need to spend too much time on it. And the last part that we think is important is pinned routes or explicit routes. We've been doing that so long in traffic engineering that I don't think we have to talk too much about it, but we think that that's a necessary component, particularly when you want low loss without doing the 1+1 protection we're looking at now. From a architecture standpoint, DetNet wants to deliver service protection. The initial solution to that is a 1+1 protection mode called PREF, but the architecture allows for other modes. For example, there's work going on in the network coding research group, which maybe will deliver something which will allow us to give the same level of protection without sending 100% more of the traffic. So from an architectural standpoint, we allow that. If you're interested in more details, that link that's going to be impossible to read, but you can download it. You can find our architecture, and it covers the whole picture. I encourage, or I ask that folks review it. We're actually getting ready to last call it. It's pretty mature. There's maybe a paragraph or two that'll change between the current version and last call. So we'd love for additional review. I think the ADs mentioned, please review documents. So this is an additional plea for that. What are some of the example scenarios we're trying to cover? So there's something inside going on in the IEEE called 802.1 TSN. This TSN, it builds on the work that was done in 802 AVB, audio-visual bridging, which talked about how to control traffic within a LAN for AV production. There was it was pretty publicized that ESPN redid their production studio years ago and threw in, one of our large vendors, switching gear to fully distribute production within a single building. That's great. You can do that with a LAN technology, but the problem there is it's limited scope. DetNet wants to marry with that technology to extend the technology like we do with L2 VPNs and be able to send what is defined in IEEE is really a single site technology into a multi-site technology. Our view is we're going to do that using the current L2 VPN technology with some additional tying together with an understanding of what the TSN control is into our TSN control, and flows, and tying that into the DetNet flows and control. Stuart actually talked about that. Well, I thought, oh, there he is. He talked about that type of service in the last meeting in the routing working group. His discussion was very focused on sort of the big picture architectural framework. It's great, it's supporting, but we're happy to take solutions right now in DetNet if you have them, and this is an important use case for us, but it's just an example of one. We also, we do IP here, right? So we want to give a native IP DetNet solution. So this is, you can take a host, it's an IP host, it goes through routers, you have an interconnected network. You will want to have subnet technology that can deliver the services that are required by DetNet. And not all networks may be equal. For example, a service may be ultra low latency. We don't like ultra high. And in order to achieve that, you'll need a certain level of control in the subnetwork. But you might be able to achieve lower congestion loss without all the TSN services, excuse me, or all the sophisticated queuing you would need on a link to achieve that. So, having your TE network today could deliver certain classes of DetNet services. One of the things that we've talked about, I can't remember if it's on the, it comes up later. One of the things we've been talking a lot about is what that IP host should do in order to support DetNet service. And one of the things that became really difficult is thinking about how do we provide this 1+1 protection from a IP host and fit into the normal stacks. And that caused us a huge amount of heartburn and cost quite a bit of time. And we've come up with an approach which is, we call the simplified approach. It came up in one of our interims. We're hoping to reach agreement that this is really the way we're going on Friday. So if you're interested in this, come to Friday. Where we give up on sort of the objective of full end-to-end 1+1, and now just do it by subnets. So you can leverage the TSN technology that allows you to do that. And if we're going across MPLS, we have an MPLS solution based on control words. They look like pseudo wires, but is an EVPN control word a pseudo-wire? I don't know. It doesn't really matter. From a forwarding standpoint, we know how to deal with them. So we have a solution for MPLS that goes MPLS edge to edge. We have a solution on a subnet of TSN. We think that's good enough, at least for an initial case. It doesn't preclude doing something fancier. If you're interested, come on Friday and talk to us about it. We have some other things that are going on in the working group. We have a security model. It's actually a pretty good document. Take a look. Please comment. One of the things that's going to be really important is for us to define what our service parameters are. We have a good start on that. We haven't finalized that. We want to be able to have a wide range of services that can be supported, from those services that are need ultra control, but also those that don't. We think we're getting a handle on that, but this is still evolving work. Eventually, we're going to have a Yang model that gives us the configuration parameters for the service as well as what happens on a node. We have an individual document. I think we're going to hopefully adopt that, but we have to see how the working group goes. But once we get that, we think we have enough information to enable control plane work. Where that control plane work happens, well, there's other groups that do control plane work. They should do those. We think we may give them some requirements, which will require some discussion in our working group. But right now, we're thinking that that goes elsewhere. But we'll see what happens based on actual discussions. I'm sure I'm over time, so I'll close with again a reminder. Come join us on Friday. We actually are going to have an extended session. The first session is a normal session. It'll feel like a normal working group. The second session is really going to be a working session to make sure that what has been discussed in our interims is what the working group wants to do. And once we have that, we're hoping to finalize the encapsulations that we're using and then make sure that our documents reflect that. So come.
Thanks, Lewis. Thanks, Janos. Thanks for the demo. Does anyone have any questions? So before you go, does anyone have any questions? Comments? Yeah, so thank you again to all three chairs. I know all three of you worked on the presentation and have been working really hard on the working group. Thank you so much. So if you don't have any more questions, we're going to go back to our regular scheduled program, which is back to the agenda. So again, we're going to go back to the administrative part now that we solved the timing issue here. So we've been busy the last cycle. A little bit busy, yes. So working group changes, we closed 3 working groups. ISIS and OSPF are no more. That of course doesn't mean that they don't exist or we don't care, because we chartered a new working group called LSR for link state routing. So now we have both of them in the same working group. We also closed Trill this week on Monday. Aliyah, one of the last things she did was close Trill. We want to thank everyone in the Trill working group who has been working for many years on the technology, and especially for the last few months as well for the getting out the work. And special thanks to the chairs, to John and Sue, and to Donald, who did a lot of the shepherding and a lot of the work. If you're here, please stand up. Thank you so much. I guess they're very tired because of all the work, so they didn't come today. We also rechartered 2 working groups. We rechartered SFC and Beer, which is now working on standard track documents. This is a big, significant change for Beer. Thank you there for everyone who has been working on that. Besides, we also had a lot of chair changes. Some of them because of Martin becoming an AD. In BEST, we actually changed both chairs. Both Martin and Thomas back in November decided not to continue. So Stefan, who's standing right there, is the new best chair, and Matthew Bochi, who is over there, he's going to stand up now, is the other chair. Welcome. Matthew has already been chair. He's already the chair of NVO3. In DetNet, because Pat is retiring, Janos is the new chair. You can stand up too, yes. Janos is the new chair. You already saw him up here. He seems to know what he's doing, so we're okay there. We have two new chairs in LSR, which are the old chairs, AC and Chris. AC, get up, just in case. Chris is probably hanging out with the Trill guys, talking about ISS stuff. That's at least what I hope. That's the only excuse I'm going to buy if they're not here. Or they're probably filling out the working group report in the wiki, which I'm sure all the chairs filled out already. We have two new working groups that are focusing on data center routing, LSVR, link state vector routing. Way back there, Gunter and Victor are the two new chairs for that. Welcome. This is Victor's first working group, and Gunter's first in the routing area. And we have also Rift, routing in fat trees. Jeff Tensura, who also chairs RTWG, is here, and Jeffrey is over there. Make sure you distinguish between Jeff and Jeffrey. If you, yes, exactly. And the other working group that Martin was chairing was Spring. So we now have Rob Shakir taking over for that. And I don't see Rob.
Maybe I didn't tell him that he had to come. So maybe I didn't tell him that he had to come.
Yeah, that's not a good start for being an AD.
Bruno de Orange. Rob is sorry he had an issue yet to miss the meeting.
So Bruno is Rob's co-chair in Spring. This is called solidarity. It's called teamwork. This is great. Thank you, Bruno. This is what we want to see in the routing area. This is the new updated working group distribution, AD responsibilities. So in case you don't remember, I'm Alvaro, that's Deborah, and this is Martin. Okay.
Pat first. Okay, we have two chairs retiring. That's what they claim. So we especially wanted to recognize them because they both have done exceptional for the IETF. So the first one we'll do is for Pat Thurler, which we only recently got her into the routing area as the DetNet chair, but she's been at IETF forever. She's been the IETF's IEEE go-to person. And as many of you know, she has been with IEEE 802 since 1985. She's been the one to chair and do different executive positions, the most of anybody there. We think her first IETF was 50. And she actually was the first one to be part of that 802 coordination group. She kicked it off. And with that, our relationship with IEEE has really improved. And so Pat, take a stand and we give you a hand. So thank you, thank you. And the next one we want to recognize is a very familiar face to everybody in the routing area. It's George Swallow. And he's been chair of the first MPLS working group, and I think even the first BOF, from what I understand. More than 20 years. He's more than 40 RFCs. His first was the tag switching, kicking off MPLS. And I don't know if on this one, if I have LSP ping, which he's also famous for. And he did the first TE. And he's mentored many IETFers, many in this room, including myself. So we really thank him for all his input, George.
Oh. I'm going to stand up for this one. So we've been saying all week, and finally it's over with. Aliyah finished her 4-year period, or her two-year periods last night at the IAG meeting when she gave her dot to Martin. We don't have enough words to thank her for all the work that she's done in the routing area. She has been a mentor to both Deborah and I when we became ADs. It was a really hard job for her, especially because of Deborah? That's just kidding. Really because she had 2 ADs. This is the first time when the routing area went from 2 ADs to 3. And Aliyah had the job to mentor both of us at the same time. We have learned a lot from her. She has been not only our guide through this, but she has been a voice for routing in the IAG and across areas. This is her positive outlook, always wanting to work with others and collaborate, has been an example, I think, for all of us. Aliyah is unique. Last night, if you were at the plenary, the IAG got her a pony. A pony is not unique like Aliyah. So today we got her a unicorn cake, a unicorn cake, which is over there. So Chris, you didn't know this, but can you unveil the cake sitting over there? We want, I don't know if Aliyah wants, but we want to share this cake with all of you. So be very careful. And do it now. Yeah, so we got her a unicorn cake because, again, of her uniqueness, we needed to get something unique. It looked really nice until Chris messed it up. So Aliyah, one of her characteristics is what?
No.
If you want to show it to everyone, sure. Everyone can come later and take a look. One of her, I think, distinguishing characteristics is Aliyah likes to talk a lot to other people, right? Not just, you know, you guys are kind of weird. So she likes to communicate a lot. She likes teamwork. She likes to foster new ideas, new people, new working groups, new everything. That is something that we've seen not just in the area, but she helped she started when she became an AD, chair chats, for example. So we sit, about once a month or every other month with the chairs. We talk about chair issues. We do training for them, etc. And this has created a really good community. You just saw Bruno come up here and cover for his co-chair. That's the kind of chair bonding that we see in the routing area. So, okay, yeah, you can take pictures as well. Aliyah has fostered a lot of communication across the area in the IAG. She has looked for working and doing outreach. She works with the Edu team. She has formed a local community in the Boston area that she organizes periodically for IETFers to meet and talk about different stuff out there. She has done experiments with the NVO3 chairs, for example, on better ways to organize rooms and to foster communication, things along those lines. So to honor Aliyah, we're going to do an experiment today. And what the experiment is we're going to eat the cake. So we have some plates over there, and we're going to eat the cake. But we still have to go do the working group updates. And John and Amy have put together some slides that unfortunately we're not going to show on the routing directorate. So what the experiment is this. We want you to all come to the front, eat the cake with us, find other people, communicate, foster that teamwork, tell other people about your working group, especially people you don't know. If you're not a chair, doesn't matter. Tell people about what you're doing. Tell them about how fabulous your work is and invite them to your working group. So we want to foster that communication to extend one of the big characteristics that Aliyah has taught us of better teamwork and better communication through that personal interaction. So Aliyah, thank you so much. We're going to definitely miss you. And you had a great impact on the whole area. Thank you. So keep in mind that the meeting is not over until 5:50. I'm serious. This is a serious experiment. We're going to measure the communication and make sure that everyone talks to everyone else. Again, we have some plates there. You can come, maybe you want to look at the cake before Chris drops it on the floor. And thank you so much. So maybe the experiment wasn't clear. Get up, come here, eat cake, talk. Yes, everyone gets a little piece of cake.
I see. That's dangerous. And the other side, this is the which is responding immediately. And if there is no problem with that, You see this happens in what's this? Which sensor which is going through the sensor. And actually, this one was somehow hit to the sensor. Actually, this right now is the blue. I see. So you are simulating. Actually, we have no if you would use so he's now simulating without preemption, right? It's actually sending big packets. Yeah, now it's got big packets, no preemption. But you can't actually use preemption because it's hardware. So he's emulating preemption by using small packets. Actually, the worst case what you would have. You should see better the yeah. If I stop the speaking, this is Now, this comes from the background. The background using maximum size. Jupyter introduced is around 125. Down. In this case, the picture study should be not taken. This picture comes from the background. So, this first report on the speed. What we have here is 100 because this board is smart board which we use from the kit. If we will use this jumbo things, it's silly because the size of the jumbo things can be of course, if you use you will have smaller. It is a package. The background mapping is a package. If one package comes and it should go to the picture, then the length of that package is
Yeah, exactly.
it's smaller size. You have to because the package the height can be vertical, but somehow it's basically standing for this small, very small packets. The packets are small, you don't see the difference. Yes, but very one word magnitude small. You can even see the effect of the background small text. But it's that you need to look at very fast. Yes, yes, have no protection, switch off the protection. But so if I generate that, then you will see first I was able to If you want to do it, you need to define it. You have to start one factor that comes to a switch that should be TSC. And then again, that must be capable factors. And you have, of course, interfaces between them. Then you need to ensure that it is correct. Yes. Actually, the idea of this display, it's well known. It's called it's a persistent vision display. So the idea is not to try. However, to use this to show that there is a problem in the network, that's our idea. And we have been thinking a lot how to show this jitter in the network. This is this persistence vision display because if it rotates very fast, you can see it. It's a good question. But whole thing put up these days. I was being removed. I'm sorry, I don't have a standardization. There we go. We cut the collars off. There is a similar board inside. Why not? It's no different than any other. Listen, there's no wrong. The next meeting is Monday. I'm not ready. I can show you. It's like here is the side, and then it goes to the we build and goes to the sensor, the fact it goes to the sensor, so this is like what goes you send finally the frame if the picture is sent one line. It's very important what is sending very precise. And also, there is a background
Yeah, that would always take
actually, we have 154 lines in the picture, but we send this in only 14 packets. So in one packet, we have 11 lines. It's not each packet is one line.
But you learn them with this. Yeah, right.
The speed of it's constant. It's programmed. The board itself this is the power supply. And also sending the which is one packet is going and when it arrives and here is starts and here comes one packet and goes back very precisely timed. This one is because actually and we reach this answer. So if there is a change in the only thing that will
I'm sorry, the picture shows like 2 hours and 45 minutes. Yeah.
always still start here. Because with this is and then starts always starts this position. But if the speed is higher, then the picture will be longer. I can actually show it. I will make it lower speed. You will see the picture itself will be like this. It will be not this long.
It's working now. They put more gum there. But you know, they have an even better demo. At ITU, they have a robot. And the robot's walking along, and when they use regular protection, the robot fell over. When they use the DetNet, well, it's TITSEN actually, but that one, it keeps going. A little bit hesitant, and it's really good.
Actually, it always starts because it's exactly the opposite position of the session. Always starts. And then it becomes wider, but when it's wider, you see that the shaking of the background. And by the right over. I start now the background. You finish. Now there is shaking.
You already drinking beer. Yeah, I'm good. We were just discussing how cheap that we drink. People with no shoes.
No more, right? It starts from there. There is a sensor that detects stock. It will send the packet which is going here on this here. Here we have rings. This block it's and receives the ticket. That ticket is sent it back. It's coming from post. This is what yes, now we have a background. If I stop the background,
Live. Simon Chan, good evening.